Okay folks, now we'll be seeing about Inodes disk usage, links and about mounting. Alright, let's go further with this. So before starting with those things, I would like you to have a quick look at the passwd file, the group file and the shadow file. Alright, okay, perfect. Let me scroll it up a little bit. Now I'm going to open up the passwd file. Okay, it's better that I tail that particular file. Okay, here I can see that the first field is my username, the second field used to be my password in this particular file, but now they have removed this particular password and moved it onto a separate file called as shadow file. Then is my user ID, then is my group ID, then I have my comments over here. Okay, here my full name is given instead of my comments. Then my home directory is given here, and at last my login shell is given here. If I were to replace my login shell with this particular stuff, I will not be able to log in anymore because this is no login prompt. Now going into group file. Alright, let me clear out this one, tail HC group. Okay, so this contains the username, then the encrypted password which is not here, then my group ID. Alright, let me clear out of this. At last I have to tail HC shadow file. This will not work because I need to be root in order to check this. Okay, so su dash given the password, then try to tail HC shadow. So here you can see my username, then my encrypted password, then the date on which this particular user ID was created, this password was created. So that is actually calculated from open up a calculator from 1st of January 1970. So from 1970, how many days have gone forward? So up to 1980 it's 10 years, 1990 it's 20 years, 2000 it's 30 years, 2010 it's 40 years. So 40 into 365, I have not counted the leap year, so leap years will be 10 days in this, right? Equal to, so 14,600, it's almost equaling this. Then the current year is 2011 for us, so I have to add another 365 odd days to that, so it's almost equaling that particular day, right? So that's how this particular date is calculated. Then this 0 is for the minimum number of days I require before I could reset my password. So if that is set to 0, I can reset the password 5 times today or 10 times today or 20 times today. That isn't a problem. If that value is set to 1, I can change my password only once every 1 day. Okay, then this is the number of days before which it's going to tell me the maximum number of days for changing password. Then the following things are the warning days. So 7 days before that occurs, it will give me a warning. Then password inactivity days, nothing is here, and password expiry days. Okay, nothing is there for those things. Now coming on to Inodes. Okay, Inodes will display, let me exit out of root. Okay, Inodes will display ll-i, or I can even put ls-il. Inodes will display the place where the particular file or a folder is stored on the disk. If I were to hit enter on this, the number which you see here, okay, is the place where the files are stored on the hard disk. So if I were to create a file called file.txt, hit on enter, ll-i, you can see that file.txt is created in this particular inode of 1216088. Okay, then disk usage command. Okay, disk usage command can be found with the du command. Okay, you have to follow that with -h for human readable stuff. Okay, and if you put it as yes, you will get only the summary file, which is the last file. So everything added up results in the last file of 26M. So if I put that, I will just get the last file alone. Okay, then disk free will show how much of my disk is free right now. So df-h will show me the size in human readable format. Okay, and how much of it is used. So 2.7 GB is used, 1.9 GB is still remaining. The percentage where it is mounted on, whether it's boot or on the root partition and stuff. Next, RHC links. Okay, sorry, I am going to take up links. So link is nothing but creating a shortcut for a particular file. There are two types of links in Linux. One is called as hard link, the other is called as soft link. Hard link, the permissions are going to be same for both the original file and the created link file. Okay, the hard link will work even if the source file is deleted. Okay, because it's going to refer to the place on the hard disk where the file is residing. Then source and destination are of the same size and they are identified by the same inode number. Okay, the way in which you have to create this is ln space source and destination. Okay, soft link on the other hand will have full permissions irrespective of the source file. Soft link will not work if the source is deleted. Okay, then destination occupies a smaller size, then identified by using file type, and the way in which you have to create soft link is ln-s then the source and destination. First we will look at hard links. Okay, ls. Okay, I have file.txt. Let me put ll-I to see that particular inode. Okay, let me try to write something into file.txt. Type on I, then hit top secret file. Okay, escape:wq. Okay, now let me clear this thing out. ll space -I. Now this shows my inode value over here. So what I'm going to do is create a link file to it. ln space file.txt to file 1.txt. hit on enter, ll space -I. So now this proves that the link file also points to the same location on the hard disk. The permissions are set the same for both the link file as well as the original file. Okay, and the file size is also the same for both. Oops, something went wrong. And the file size is also going to be the same for both the files. Alright, now I'm going to do I'm going to remove file.txt. Okay, now if I were to cat file1.txt, top secret file. So even if the source is deleted, we still have the destination. Alright, so that is for hard links. Now coming over to soft links. ln-s file1.txt. let me move it back to file.txt. Okay, l-I shows me that this is the original file and this is the soft link file. Okay, soft link file will have the first character of the permission set to L. Okay, for directory it will be D and normal file it will be a hyphen. Okay, all the permissions will be set for soft link. Okay, the size is considerably smaller compared to the original file, and the soft link is pointing at my original file over here. And if I were to cat file.txt, I can see that, but if I were to remove file1.txt, which is my original file, and cat file.txt, I cannot detect any file or directory. If I have to put ll-I, so the color became red because that file no longer exists. Okay, the next one is mounting and unmounting. Say if we were to put a CD-ROM or a pen drive or a DVD, we need to mount those devices on the file system so that we can read and write to those files. So even if we have for external hard disk, it will usually appear as HDB1 or HDB2, SDB1 or SDB2. S will be there for SATA drives and H for PATA drives or IDE drives. Then fdisk-L will show us all the devices on our system so that we can mount the appropriate device. Leave fdisk-L. Oh, I have to be root in order for this command to work, because these will affect the system level stuff. So this is an IDE device, so HDA. So if I were to insert a pen drive, it will show as HDB and so on. Alright, and unmounting, after mounting it and copying and saving files onto your external device, you can unmount the destination and pull out that particular device. With this, we conclude inodes, disk usage, links and mounting. I'll cover mounting like in depth while I do some other video tutorials, probably like in RH133, that particular topic will appear. Okay, thanks a lot for viewing this video. Bye bye.